Happy Canada Day, everybody. This year we are custom engraving a Rask knife with a maple leaf pattern, and I want to show you guys the process of engraving that knife. Let's go. So this knife here is 1867, which is the year that Canada was kind of born, created. We finished it about a month and a half ago, and we're like, oh, we got to save that knife for Canada Day. So here we are. So I'm going to take it apart. I'm going to engrave a maple leaf pattern on both sides. I did an experiment. So a while ago we made these maple leaf pivots, which look super cool, but we haven't really used them yet, so it's time. The guys in the front shop tumbled it to kind of get rid of the machining marks, give it that beautiful tumbled finish. Turned out great. And this is our concept. So this was my first engraving example. I wanted it to radiate from the pivot and get bigger, bigger, bigger. This was actually Angela's idea. He's had it for like a year, so we finally got to try it. There it is. So the maple leaf just gets bigger, 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 bigger. Turned out really good. The end mill that I'm using is a Lakeshore Carbide tapered engraving end mill with a 20 thou ball and a NACO coating. I really, really like these engraving end mills. They're super strong. The tip can break if you're not careful, but it leaves a really good cut and it works great. So on the test engraving, let's go into the microscope and see what a halfway used engraving end mill does, because this is kind of interesting. Okay, so while engraving this handle, the tool that I'm using is about halfway through its life. I don't remember the numbers, but let's say it's 300-minute life. It's at about 150, and that's just what I remember from yesterday. As the tool wears, it's not going to cut as cleanly as it normally does. So really interesting under the microscope what this thing is doing. So if we look here, and I get the focus just right, this is where the difference between climb milling and conventional milling makes a gigantic difference. Because basically, here's my thumbnail, we are dragging the tool, I mean we're spinning it, but we're just doing a single pass through. I am stepping down multiple thou at a time, but still, it's not stepping side to side at all. And so if we're climb milling on that upper wall, it means we are conventional milling on this lower wall, and that's why the lower wall looks so fuzzy and is leaving all this junk stuck to the sides, because it does not like to conventional mill. So, perfect example. Upper wall looks clean, climb milling, lower wall looks gross. In order to solve that, I think I can get away with same depth, same step side to side, but do it twice. Climb mill in one direction and then conventional mill in the other direction. Basically means going clockwise once and then going counterclockwise again, and that should clean it up. Ideally, normally I'll step over half a thousandths to the left and then half a thousandths to the right, and that'll clean up both walls. But here I think I can get away with just kind of a repeat pass, but in the opposite direction. Because this is not sellable, this is not good. This is gross when you look at it super closely. And here's the opposite. The lower wall is clean, the upper wall is fine, which means my direction must have been opposite. So, good. This is why we test. It's a good experiment. And it's not feasible to actually go in and clean this up by hand. You're going to scratch it, you're going to screw it up. I mean, watchmakers will, but that's not what we're doing here. We can improve the process to avoid the problem. Here you can see in the fusion side, with my in-process stock turned on, so you can see that it's actually been cut. I like it. It's just purely sketch driven. Okay, so here's my sketch. And I simply started from a small one, and at first I tried to offset, but it changes the shape. So offsetting doesn't work. I have to scale it. So I would copy it, paste it, select it, scale it bigger, 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 and then I drew this big fat outline, which is bigger than the part itself. And then I trimmed it. I used the trim tool to trim, and then I put a mirror line there and I mirrored it over to that side. Okay, so I've got two operations. One is a roughing and finish the one wall operation, takes about 5 minutes. The other is simply a finish operation, only takes a minute and a half. You can see I'm stepping down 4 times. And if, for example, I'm going down and over, down and over, down and over, down and over, that's going to finish one of the walls perfectly. And then the second operation is the exact same toolpath, except I clicked other way so that it will go this way instead. And without stepping side to side, that should clean up that other wall. So my question that I have to answer to myself, tool 41, is currently at 208 minutes out of our 400 standard life. Now, normally, whenever I engrave an already anodized handle, like so, I want to use a brand new sharp end mill because that just cuts better. It cuts through the anodizing better, it doesn't chip, it doesn't kick up a burr. I'm trying to be lazy and not replace a $25 end mill too early, but maybe I should. Yeah, I guess I should. Maybe I'll even put this one back afterwards. Let me do that. Epic tool change sequence. Initiate. Boop. 41, 41, 41, 41, 41. This is a two-handed operation. 41. Placeholder. Done. Coolant inside. Sweet, tool holder assembly assembled. This is a Rigofix hydraulic unit, and it's hydraulically pressing the collet into the holder. Super awesome. And then we've gotten into the habit of always cleaning off the tip of the tool in this Rodico putty. It's a watchmaker's putty. Careful, obviously, not to hit the tool against the thingy. Clean the tool. Okay, then we need to tell the machine to touch this tool off. I'm going to cheat a little bit. In tool 41, can you see this? I go edit, I go to time 1, I type 998. That's my cheat. That's not going to reset my 208 minute life, because I'm going to put the old tool back. Take this out, put this back in here. So now it's going to touch off the tool, but not reset the 208. It's going to add 5 minutes to it, whatever. And then afterwards, I'm going to put the old tool back in so I can get the rest of that 200 minutes of life. Time to take knife apart. Alright, got my two handles. On my fixture here, we've been developing this for quite a while, more and more. Even got draining grooves here to drain excess coolant when it's sitting. Okay. There's alignment posts to make sure the handles go on the same way every time. Little tiny screws that go in from the back side and go into threaded holes on the back of the knife. This center pallet goes onto the main tombstone. Let's pull that out right now. If you remember from early Kern days, this is the first tombstone we built. I was hogging it out, it was vibrating. We filled it with this epoxy settling stuff. I can't remember what it's called. So we filled it with that, didn't really fix it. Eventually we just redid that entire design and went to this design where it's hollowed in the middle and all the way secure around the outside, no more vibration. This is more of a C shape where the vibrations just go zoop, zoop, zoop. Didn't work. Anyway. Install center pallet. There's a locating pin there and a locating pin there. And it goes in. Boop, boop. I get 4 screws and I tighten them down. We've been really loving this Sandvik branded micro torque wrench. Measures in Newton meters. We've got it set to 9 Newton meters, which is the M6, metric M6 torque spec. Really, really love it. Use Torx Plus bits. It's been awesome. Here's the part number if you want to search it out. It's great. We've got like 4 of them. They're like $200 or 150 or something like that. Kind of expensive, but we torque almost everything, so that's good. All right, pallet going back in. So now on this honker, this pallet's also a lot heavier than the other ones. I've got the finished handles installed. Here we go. Canada Day engrave. Send it. So it should tool change to tool 41, and it should automatically touch it off as the first part of the code, because tool call 41 and then run time 1 touch. But just in case, I'm ready. There you go. Touching off with the Bloom laser. So right now it's touching length, and it might also touch diameter, but for a tapered ball that's irrelevant. It's just part of the default cycle. I saw the tip light up there with the laser beam. All right, easing into it. We're good. It's gonna run for about 5 minutes. I love it. I do love how Heidenhain has this scroll bar. Fanuc does not. Heidenhain, yay. Almost done. 8 minutes. Almost done. Almost done. Here it comes. Boom, done. Now it's going to do a tool breakage check, make sure the tool is still there. And there we go. Complete. Oh mama. Look at that. Oh, that looks really cool. Got the GoPro mounted right on the Aroa arm. Pretty sick. So now I have to remind myself that this machine is not a toy and I have to get back to production. So I'm gonna get back to the regularly scheduled pallet run, which is right over here. It's gonna run Rask, 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 Rask Blade, Norseman, Norseman. It's gonna run all night. Not bad. Still gotta be cleaned up, still oily, but oh, I think that looks great. Very nice, crispy engraving, no burr. I guess we can go to the microscope and look, but I'm pretty confident. Here's the deal. Fresh end mill, brand new end mill, gently cutting, still leaves a tiny, tiny little bit of a burr. Check this out. So just little bits on the sides. I mean, trust me guys, everything under a microscope looks worse. This is the life we live with. When you look at something this close, everything is gonna look bad. So I am choosing to show you something that looks worse under magnification to educate you guys, not for you to flame me and say it looks terrible. Just is what it is. But I wanna show you, it does kick up a tiny little bit of a burr on the left and the right walls. Cutting metal does that. This is where tumbling comes into effect, blasting, things like that can help clean things up. But since this is a finished knife, already anodized, we don't want to do that anymore. I want it to be done. So these burrs are so small that they kind of just come off with your fingernail or fingerprints just from use. They're gonna wear down. I'm really not concerned. I mean, this is very magnified. Like, that's a 1/875 hole. This is my thumb. Like, even my pinky is huge. So these burrs are very, very small, but they're there. So coming off the outside of the part, kind of interesting. Little bit of a burr on the back edge here. I can just catch my nail on it. Not an issue, just pointing it out. I think it looks really, really good. Sweet. All right, so thinking about those burrs overnight, it's the next day. Still didn't feel amazing about them, and then I showed Angelo and Sky, and they're like, we gotta do something about that. So Angelo right now tried a couple things. They tried a pencil eraser, and now he's figured out that a popsicle stick does an amazing job. Let's get closer and look at that. So how's it working?
Seems to be working. We could add maybe a tiny bit of an abrasive, but I'd rather just not. And I'll go in here with something like a little pick or something, and then just get it in the corners. Looks good though. Looks a lot better. This is being OCD in the machine shop.
Yeah.
I feel like a watchmaker.
Exactly. That's what I mentioned yesterday. I'm like, only watchmakers would get in here and do this.
And then you saw it.
Yeah.
Yeah, and here I'll probably go with a toothpick. The toothpick would actually be really good in there. And you could probably buy toothpicks with abrasives loaded on them too. Yeah. In the future, start to get into.
Yeah, it's tricky on a finished part because you don't want to scratch the anodizing.
Nope. Yeah, it looks so pretty. It's pretty crazy to see it so close up. Each of these little marks is a stone, you know, that creates a really beautiful finish that's extremely wear resistant in terms of its, you know, how the finish is going to hold up. Pretty cool.
Sweet. The other thing I realized is that the tool I'm using is like a tapered ball engraver. So the tip is a ball, but the side walls of that engraving are actually tapered. And that's what's leading to the burr, is the kind of the sharpness of that tool. If we used more of a ball end mill and only did like the depth of the little bit of a ball, you'd have a wider groove, but the side walls would be more like this and not like this. So it would have less burrs naturally to use a ball, like a sharp ball, and not go past the radius of the ball. But we didn't do that. So this is what we have to deal with. Grayson had an amazing idea to sell this 1867 Rask with a matching pen with a maple leaf button, and sell the whole package in Canadian dollars, which we were going to do only to Canadians, which we were going to do, but do a knife pen combo and charge 1867 Canadian for both, which almost perfectly works out. I think that's a good idea. So check out this button here. This is our maple leaf button. I think it'll look good. They look so good. They both match, the Rask and the Saga. They have, we did a blasted, tumbled, anodized finish, which we almost never do, but Sky has been playing with that. And they just look stunning. Woo! It's almost a shame that some of these collector pieces I know never get used, never get carried. They become collector pieces. All the work we put into it just gets admired and displayed, but these are made to be used as well, whatever. Worked out great. Over the weekend, we did an Instagram name draw where Ryan put up a whole bunch of great pictures, made a nice subscription, and a whole bunch of Canadians and some non-Canadians that we had to boot off signed up. So I want to thank you guys, Canadian guys. A lot more people signed up than I was expecting for, and I really, really appreciate that. And we picked a name, emailed him. It'll be shipping out very shortly. Selling a kit like this has always been a dream of ours, you know, knife pen combo, and doing it now obviously makes us realize what we've wanted to do for a while is to make a combined foam that has knife and pen in one case. We're not there yet, but it shows me that I want to get there. I want to design that foam so that you can sell it as a kit. It's super cool because I mean I carry, this is in my pocket right now. So yeah, we'll be doing that sometime soon. Anyway, thanks for watching, guys. This was a fun little project, and I do have some more customized projects coming up that I want to get off my to-do list. So stay tuned for that. A lot more videos coming up. We're on a good streak right now. So thanks for watching.